All right, we are going to continue with 8.5 part 2. This is on the complex fractions bit of this. So you'll see down here we also have steps. So we need to find a common denominator. We're going to call that CD. We're going to multiply the common denominator, and then we will simplify. So you'll take a look here. You'll notice what makes these complex fractions is not that there is an imaginary number in them, but that there is a fraction within a fraction, or that there is 2 or 3 fractions within a fraction. Okay, so these actually aren't the hardest to solve. It's kind of what we were doing in the first part of this lesson. They just are a little long, okay? So I'm actually going to show you 2 ways to solve this. The first way is not necessarily following these steps, but what helps me really visualize what's going on. And then the second way is what will follow the steps above. So how I learned this and how I like to do it is I like to go ahead and just isolate this part, the denominator, okay? So I'm going to isolate my denominator, and I am going to pretend that is my only problem. I'm going to try to get these to add or subtract, in this case subtract, using my common denominator. So in this case, my common denominator is going to be me multiplying each fraction by the opposite fraction's denominator. So I end up getting, so y times 1 and x times 1 is just 1, so I end up getting y over yx minus x over yx, which is the same thing as y minus x over yx. Because we have common denominators, you can just subtract straight across, like we saw above. Okay? So from here, this is my new denominator. It is equivalent to what is written in this box. It is just under 2. Okay? So now we have 2 over y minus x over yx. So now I can think of this actually as 2 over 1. So really, any whole number can be written as a fraction just by putting it over 1. So now I have a fraction within a fraction twice. Okay, so now to get our fraction within the fraction out of the denominator, you can simply multiply the denominator by its reciprocal, and then you can do the same thing to the numerator. Not multiplying the numerator but by its own reciprocal, but multiplying the numerator by the denominator's reciprocal. So you'll notice in the denominator, everything cancels out. Y minus x cancels out. Y times x cancels out. You are left with nothing in the denominator. You now only have to deal with multiplying 2 fractions. So we have 2y times x over, so 1 times y minus x is just y minus x, and you have your solution. So you can do that. That is the way I prefer to do it. That's the way I learned. It makes sense to me. There is another way we can do this using our CD, or common denominator. So let me scrunch all this up and we will try the second possible way. And then I'll show you each of the following problems, only one of these ways. Okay, so the second possible way, you need to use the common denominator, or CD. So we still have to figure out what the common denominator is between all of the current denominators. So that includes 2 over 1 1 over x, and 1 over y. So we need to look at the denominators of all three of these. So basically, you can usually just take the denominators multiplied by each other, unless one of them is repeated. So we can have 1 times x times y. The 1 doesn't really change anything, so our common denominator is xy, or yx, maybe would be a better way to put it, since that is what we used previously. Okay? Or, you'll notice that this is the same thing as writing y times x over 1. You can think of it that way too. It really means the same thing. So now, since we have found our common denominator, we can multiply each of these guys. 2 over 1, 1 over x, and 1 over y by that common denominator. So we can say, okay, a common denominator, y times x. We are multiplying each of these. I should make that distinction. From here, we have set it up that we will have things that cancel out. So in this case, let me put it in red, we have the x's cancel out here. We have the y's that cancel out here. And the numerator, since this was just a 1, we don't even need to necessarily have those guys there. I just put them there to distinguish that. You can go ahead and just multiply straight across now. We have 2 times y times x over, in the denominator, well, there's nothing left in the denominators. So we have just y minus x left. You'll notice, using the common denominator or the first method, you get the same solution either way. Okay? This next one, I'm going to do the first possible way to solve. And then I'll follow that up with the second possible way to solve on the last one. So, here we go. I'm going to use my method, where I go ahead and find a common denominator of the denominator. Gets a little confusing since they're all called the same thing. Notice, since this is subtracted by 2, we can't really just multiply by 2 or anything like that. Subtraction mixes it up, so we're actually going to have to multiply by each denominator's opposite of both the numerator and denominator, like so. So this guy comes here and here, and this guy comes over here. We end up getting 5 times x minus 2 plus x over x times x minus 2. Now, it would be super tempting to just go ahead and reduce these guys. Unfortunately, since there's another addition of an x over here that we do not have, we can't do that. So, instead, I'm going to go ahead and distribute this 5 through. I get 5x minus 10 plus x over x minus 2. Okay, so combine like terms in the numerator, we get 6x minus 10 over x times x minus 2. We could distribute that. That is not super helpful to us right now. We could also just factor or pull out a greatest common factor here, but I'm going to wait and see if I actually need to do that. Because right now, I just found the simplified form of just the denominator. I am not done yet. I have to put that under our numerator of the whole entire thing. So let me move some things around. this is our denominator. We need to put that under our numerator, which is 7 over x minus 2. Since everything is nice and concise in our denominator, the whole denominator, I can go ahead and multiply by the reciprocal. These guys cancel. These guys cancel. Don't forget to do it to the numerator as well. We are multiplying still. Now, since we are multiplying, and there is no addition on either of these guys, except for what is in parentheses, I should say addition or subtraction, those x minus 2's can cancel. And then you can just multiply straight across and get 7x over 6x minus 10. And we are good to go. That is our complex fractions simplified. Okay, lastly, I want to use the second possible way to solve. That means I'm going to use that common denominator. So I need to look at all the possible denominators and find a common one. Now, unfortunately, there is no repeated denominator or anything of that sort. So we actually are going to use all of these multiplied together to form our least common denominator. Like so. Okay? From here, I'm going to put that over 1. And then I'm going to multiply each of these by that common denominator. We have set it up so that way things will cancel and we will no longer have these denominators anywhere. It will be down to just one fraction. So let's see, I'm going to rewrite our problem so that way it's big enough. And I'm going to put our common denominator in a different color. So I have times 5x times x plus 2 over 1, and the same thing for each of these. You could think of this all being in parentheses and distribute it through. Might be a better way to think about it, but I like writing it by each, and it won't mess me up. Okay, so now in red, I'm going to cancel what I can out. X plus 2's cancel out for our numerator. X's cancel out for the right part of our denominator, and 5 cancels out for the left. Notice how we are left with only 1's in the denominators all the way. That means we don't need those anymore. You could rewrite this as 3 times 5x over x times x plus 2 times 2 times 1 times 5 times x plus 2. That's really what it's saying. Obviously, we're going to condense that down to make it prettier. Oh, I'm so sorry. There's a plus here. It's not 2 times 1. It's 2 plus 1. There we go. So we will condense this right side. Oh, sorry, this left side, I should say. And then we will condense this right side and have them added. So we have 2x from these guys. Times x plus 2. Plus 5 times x plus 2. Over 3 times 5x is pretty fast. That's 15x. Okay? So, there's 2 different ways we can solve this and get a solution. We can either factor by grouping. If you recall, if we have x plus 2, something similar looking to that, and there's 2 of them, you can actually factor that out from each, the 2x and the 5, and you can be left with 15x over 2x plus 5 times x plus 2. That might be what Math Excel would want. Or you could distribute and combine like terms. Oops, I forgot the x here. Here we go. Or you can distribute combine like terms, 5, 15x over, I'm going to do it all in one step. You end up getting 2x squared plus 9x plus 10. These are truly equivalent. They mean the same thing. They're just two different ways to write the solution. And we can't simplify any further, so we are good to go.